common factoring. Now, we're going to be doing a whole bunch of factoring in grade 11, and in grade 11 you are going to be responsible for 4 types of factoring in grade 11U. There's going to be common factoring, factor by grouping, trinomial factoring, and difference of squares factoring. And you're going to have to be an expert on all of them. And again, this is a review of grade 10. This is not grade 11 work yet. This is stuff that you should be coming into this class knowing very well. Review of grade 10. Now the reality of it is, I know that we're all at different points, and so a little bit of practice is going to help us when we go to do our grade 11 work. So common factoring is what we're going to start with. We're going to start today with common factoring. There's another video after this one on the LMS. You're going to take a look at factor by grouping, and I'm going to move you into trinomial factoring, and by the end of the week we'll be done difference of squares factoring. The whole thing here, guys, is practice, practice, practice. There is no substitute for just getting in there and doing these questions. Not a good idea to do your homework all in one sitting. I would break it up. I would do a little bit of math and do some biology and then come back to it and do a bit more factoring and then go do something else and then come back to it. 3 hours, an hour and a half sitting there plugging away at factoring is not going to be as effective as 3 20-minute periods during the evening. It's the type of thing that repetition at different times is going to make you skillful. So common factoring, that's what we're going to start with. We're going to talk about common factoring first. And common factoring, you must always try first in all questions. It's going to make your life easier in the long run. If you don't do this first, then you're going to have questions that are going to be ugly, they're going to be long, they're going to be tedious, and you're going to see that if you had common factored them first, your life would have been made much more easier in the factoring arena. So, moving on, to find the greatest common factor, okay? That's going to be different than the lowest common multiple. That's a different thing. Multiple and factors are different things. We're going to talk about that later on, maybe in a week from now. Right now, we're talking about a greatest common factor. What's a factor? Well, a factor is when I take something like 12 and I say that the factors of 12 are 6 times 2, or 4 times 3, or 2 times 2 times 3. All of those give me factors of 12. And what factors are the things that you multiply together to get what you started with. So if we multiply these together, you end up getting back to our original 12. So these are factors. 6 and 2 is a factor. 4 and 3 is a factor. 2 is a factor. Now, what is the greatest common factor of all of these that I talked about? Well, probably 6 is the largest. That's my greatest common factor in this thing. Now, we're going to talk about greatest common factors in terms of series of terms. So I've got a term, 2, 3 terms. I've got 1, 2, 3 terms. This is only a single term. So talking about the greatest common factor is going to look a little bit different when I come down to these multiple terms, and that's what we need to talk about next. So I'll get rid of this. So what is a greatest common factor? Greatest common factor is going to be the greatest common factor of the coefficients. And really, maybe if I want to be more accurate, I should say numerical coefficients. But in any way, I'm talking about the numbers. And the literal coefficients, the variables. So we're going to have to take out the greatest common factor both in the numbers and in the variables, and that's important to realize. We're going to be looking at both numbers and variables when I'm looking for the greatest common factor. All right, examples. State the greatest common factor of each of the following. So I'm not factoring these, I'm just stating what the greatest common factor is. Well, I've got 3 terms here. I've got this 4 times A times B times C. And then over here, I've got negative 12. Well, there's a 4 in there. There's a 4 in there. There's a 4, negative 3. So 4 times negative 3 is negative 12. And I've got an A, a C, and a D. And then what do I have over here? Well, that's a 16. Is there a 4 in there? There is. There's a 4. And a 4 times 4 is my 16. And there's a C. And there's a Y. And there's an A. So I'm looking at this a little bit differently, right? I'm looking at these terms. I've broken them up into, let's see if I can do something here. I want to do that, and I want to do this. And that I can make that a little bit smaller so it doesn't take up nearly as much room. Okay, so what I have here is these are the expanded terms that I have listed here. So I have them expanded out. These are factored. So I've got factors here, and factors here. So I'm looking for the greatest common factor for all three. So what is the greatest common factor for all three? Well, guess what? We went through there and we noticed that there was a 4 in all of them. Each one had a 4. So that's common, don't you think? That's a common factor. That factor of 4 shows up in all three of them. 1, 2, 3. So it is definitely a common factor. So 4 goes there. Now, is that everything that can come out? Because when we talk about a common factor, a greatest common factor, we want everything that can come out. Well, let's take a look. In terms of numbers, this has a 3, this has a 4, this doesn't have any more numbers. So no, that 3 and that 4 can't come out. They're stuck in there. But what about in terms of the variables? Well, I have an A here, an A here, and an A here. They all have an A. Isn't that cool? That means that the A can also be a common factor for all three, because there's one here, there's one here, and there's one here. What about anything else? Well, I've got a, that was awesome. I've got a B here. I've got no B here. So already that B is not a common factor because it's not in this one as well. So B, sorry, buddy, you're not part of the common factor. What about C? Okay, that's good. There's a C there and there's a C there. Whippy! We have a C in all of them. So C is also a common factor in all of them. Now, what about anything else? How about D? Well, there's no D over here, so, D doesn't win. What about Y? Well, no one else has a Y, so no, Y is not a greatest common factor. So between these three things, our greatest common factor is a 4 and an A. Now think about that. Can you see the 4 and an A in there? I can. Can you see the 4 and the A sitting in the 12? And it's going to leave me with a -3, right? Okay. And can you see the 4 and the A? There's a 4 in with the 16, and there's the A there. Now, I haven't factored it. I have not factored these things. I'm just telling you what the greatest common factor is. All right, let's look at the next one. 3 terms, 36, 12, and 8. Well, they all have 2 in them. They all have a 2 in them. That's great. Yep, there's definitely a 2 in 36 and a 2 in 12 and a 2 in 18. Is it the largest number that goes into all three? I don't think so. 36. 36 reminds me of, 36. I think it should be 6 times 6. And how many X's do I have? Well, I have 1, 2, 3, 4 X's in that one. What about the 12? Does it have a 6 in it? It does. It's 6 times 2. And how many X's? Oh my goodness, there's 5 X's. This can go on forever. 1, 2, 3, 4, 5 X's. And what about the 18? Does it have a 6 in it? It does. It's 6 times 3. And how many X's? Only 2, because it's X squared, right? All right, so the greatest common factor now. Greatest common factor. What is common in all of these? Well, lo and behold, there's that 6 we were talking, right? So there's a 6 in all of them. But what about the X's? Oh, well, what about any other number? This one has a 6. Oh, that was bad. This one has a 6. Where'd it go? Where'd it go? Come back. There we go. This one has another 6 left over. This one doesn't have another 6. It has a 2. So, hey, I could take a 2 out of this 6. That would leave me with a 3. And I could take a 2 out of this one. That would be good. So is there a 2 left over in this one? No, there's not. There's only a 3 left over in this one. Okay, well, I could take a 3 out of this one, and I could take a 3 out of this one, but I can't take a 3. So no, it has to come in all 3 of them. It's a greatest common factor of all 3. So the 6 is the best I can take out in terms of the numbers. What about the variables? Well, X is definitely coming out of all of them, but the question is how many? I've got 4 X's here, I've got 5 X's here, but I only have 2 X's here. So guess what? This guy is limiting the total number that can come out. He's only got 2. So I can only take 2 out of that one, and I can only take 2 out of that one. They have more, but I can't take more than just those 2 X's out. So it's gonna be an X times an X, which we'll write as X squared. So my greatest common factor here is 6X squared. Now, can you see that up here when you look at these? When you look at these later, can you sit here and say, okay, I'm going to take out a 6x squared from here, a 6x squared from here, and a 6x squared here from there. And it kind of makes sense because 36 divided by 6, 12 divides by 6, 18 divides by 6. I've got 4 x's, I'm taking 2 out. I've got 5 x's, I'm taking 2 out. I've only got 2, and I'm taking 2 out. And that gives me my GCF. All right, moving on. Let's do another one, getting more interesting. So I've got a 6, a to the 4, x to the 4, y to the 3. So looking at the number part first, let's sort of streamline what we're doing. Let's make this the GCF in terms of the numbers. So I've got a 6 and a 12 and an 18. Well, a 6 goes into all of them. Okay, so it's going to be 2 times 6 and it's going to be 3 times 6. What about A's? Do they all have A's? Well, they do all have A's. So this one's got 7 A's, this one's got 2 A's, this one's got 4 A's. So the most I can take out of all 3, remember it's the greatest common factor, the most I can take out of all 3 is only 2. What about X's? Do they all have some X's? They do. I've got 4 X's here. Ooh, that was bad. Let's bring this back. I've got 4 X's here. I've got 3 X's here. And I've only got 1 little X there. So the most I can take out of all of them is only 1. And what about Y's? Well, 3 Y's, 5 Y's, 7 Y's. The most I can take out is 3 out of all of them. And that's my GCF for those guys. All right, moving on, moving right along. Let's look at this one. So let's look at the numerical value first. I'm looking at the 12, the 15, and the 3. So I'm sort of doing this in 2 steps, people. I can't do this all at once in my head, and I'm not trying to. I look at the numbers first. 12, 15, 3. Well, guess what? 3 goes into all of them. So that's A-okay with me. Now let's look at the A's. A to the 4, A to the 2, and A. Well, the most I can take out is just 1 A. C, I got 2 C's, C squared. I got 3 C's, C to the cube. I've got only 1 C. So the most I can take out is 1 C. And that's my GCF. And that's how you do it. Now, take a look at this question. A little bit different. A little bit different, but not really. No, not really. Let's look at it. Let's look at it. So this is multiplication. This is 3 times a bracket, and the bracket is x plus 5. And then you've got x plus 2, and you got another bracket of x plus 5. And then this one is a bracket x plus 5 and a bracket x plus 5. So this x plus 5, this bracket of x plus 5, okay, I've got it everywhere. I've got that bracket x plus 5 in all 3 of them. Let me really write this out so you see it. Here it is here. I've got a 3 bracket x plus 5. There it is right there. And then here, I've got an x plus 2, and I got another x plus 5. Look, it's right there, x plus 5. And then the next one, I've got an x plus 5, and another x plus 5, because that's what x plus 5 squared means. So now really look at this. This is here, this is here, this is here. What is common in all of them? An x plus 5, the bracket. So the GCF here, that's not good. Get rid of that. The GCF here, the greatest common factor is x plus 5. It's a binomial. And that's okay. That works. It's beautiful. It's a good thing. We'll do some more work with that. Now let's see what this says. This says that to factor an expression, means to write it as a product of two or more terms. Read that again. To factor an expression means to write it as a product. Multiplication, that's what product means. It means multiplication. Multiplication. That's what product means, of two or more terms. Notice what I have to say next, that factoring and expanding are reverse processes. So factoring and expanding are reverse processes. So here's expanding. Expanding is the process of expressing a product as a sum or differences of terms. So this is your multiplication. This is A times B. That's a product, and we're expressing it as a sum. A plus B. Now, these A's don't equal each other, so let's get rid of that because I don't want to confuse the issue, but it equals D plus C. So I took A times B and made it equal to D plus C. That's expanding. You take multiplication and you change it into addition or subtraction. Factoring, however, you take the sum or difference and express it as a product. So you take it from addition. So here's my addition. You've got A plus B here, and I'm changing it so it's now D times C. And the D is my GCF. It's that 5. So look at my example that I have here. Expanding is my 5 going into the A and the B, giving my 5A plus 5B. And if I start with 5A plus 5B, factoring is taking the GCF out. And this is what's ever left once you take the GCF out. Because once you put the GCF back in, you end up going right back to where you started. And that, ladies and gentlemen, is a recap on factoring. Now let's do some examples. So examples, common factor each of the following fully. Common factor. So I'm going to look at this. I've got a 6A and I've got a 10B. What I want to do is I want to take the GCF out and I want to leave it multiplied by whatever is left. That's the idea here. So my GCF here is going to be 2. There's a 2 in 6A and there's a 2 in 10B. The 2 is in the 6, the 2 is in the 10. And there's nothing else common. So this is going to be 2, 3A minus 5B. Now look at that for a minute and make sure that makes sense to you. I have a 2. It will go back in to be 2 times 3A, which is 6A, and a 2 times negative 5B, which will go back to give me negative 5B. So let me erase all of that and do that one more time with you. So what we're looking to do here, what the whole game plan is to take the GCF out and you have left over what is left once the GCF is taken out, okay? So look up here. When we factor, what we do is we take the GCF out and you're left with whatever is remaining once the GCF is removed. So I want to figure out the GCF for each of these, and then we'll figure out whatever's left over, and they are going to be multiplied together. So in this case over here, what we have is I have a GCF of 2. It's the only thing that goes into both of those terms. We take the 2 out. What are we left with? Well, 6A divided by 2 is 3A, and 10B divided by 2 is negative 5B, and we're done. And we're on a roll. Let's do the next one. So I've got 12, 4, and 20. So the GCF, the largest numerical factor, is going to be 4. 4 goes into all 3 of those numbers. And this one has an x squared. This one has an x, but this one has no x's. So no, you cannot include x in the GCF. It is not a common factor because the 20 doesn't have it. But they do all have 4. So what you're left with is, what is 12x squared divided by 4? 3x squared. What is negative 4x divided by 4? Negative 1x. And what is 20 divided by 4? Positive 5. And so we look at that and make sure that it's right. And how do we do that? We go backwards. 4 times 3x squared is 12x squared. 4 times negative x is negative 4x. 4 times 5 is positive 20. So you can always check all factoring all the time. Do it in your head. You are always, always, always supposed to check. Let's look at the next one. So I'm looking at this question. My GCF, it looks like I can take a 5 out of 15 and a 5 out of 50. So there's my 5 on the outside. But I can also take an x out of both of them. So I'm going to take a 5x out. It's going to leave me with 10x plus 3. Let's see if that makes sense. So we're going to check it in my head. 5x times 10x is 50x squared. 5x times 3 is 15x. Life is grand. Let's keep going. Alrighty then. So I've got 3 terms. 1, 2, 3 terms. Let's look at the numbers. 8, 7, and 10. Well, 7's a prime number, so it has no factors that go into it other than 1 and 7. 10 doesn't factor by 7, and 8 doesn't factor by 7, so there's no numerical common factor. Let's look at the variables, however. I've got A and a B. Well, the B looks good, right? The B looks good. The A's no good, but I got a B here, I got a B here, and I got a B here. That's the only thing in common in all 3 terms. So that's the only thing that comes out, just a B. What are we left with? Well, when I take 8AB and remove the B, I get 8A. When I take 7BC and remove the B, I get 7C. And when I have 10BD and remove the B, I get negative 10D. Now let's check if I'm right. 8A times B is 8AB. 7BC and negative 10BD. Life is grand. Let's look at this one. I've got 2x plus 3. I've got 2x plus 3. Looking at my numbers, I got 4 and 9. 4 and 9 had no common multiples, but the brackets are the same. The brackets are definitely common. So let's take the bracket out. We take the bracket out. And what are you left if you take the bracket out? Well, if I take out this bracket, I'm left with 4. And if I take out this bracket, I'm left with 9. And guess what that is? That's going to be 2x plus 3. And 4 minus 9 is negative 5. And that is factored. And if you wanted to, you could write that as negative 5, 2x plus 3, because the order of multiplication doesn't matter. And they're both perfectly fine. What's next? Look over at the far one. Look what I got over here. I've got a 2x and I got a 7x plus 5. And I've got a 7x plus 5 squared. So that means that there's 2 of them there. So in fact, this is 2x, 7x plus 5, plus 7x plus 5, 7x plus 5. I've actually got 2 of them sitting there. I got one of them sitting here. I got one of them sitting here. That means that those are common. So let's common factor them out. We'll take out a 7x plus 5, and what are we going to be left with? Well, if I take out this, I'm left with 2x. And if I take out this, I'm left with plus 7x plus 5. And that's an answer for the factoring. That's not a problem. The only thing is we could go a little bit farther here if we're thinking. As long as we're thinking, we know that we got a 2x and a 7x. So we might as well put those together and simplify this nicer. And you're going to get 7x plus 5, 9x plus 5. And that's what we have as our final answer. And notice we took addition and we've made it into multiplication. There are 2 terms here being multiplied together. And that is what factoring does. Well, I've got 1, 2, 3, 4, 5, 6 more examples. I'm not sure why I have 6 more examples, but I do. So let's finish them off. Let's look what the greatest common factor is going to be here. Well, it looks like it's going to be 6, and I'm going to be left with x minus 3. Checking it in my head, I'm going to take the 6, times it by x is 6x. Take the 6, times it by negative 3 is negative 18. I am correct. Let's look at the next one. I got 35 and 10. So I can take a 5 out of both of those. I've got an A in both of them. I got a C in both of them, but they don't both have a B or a D. So the A and the C come out. What am I left with? 35 divided by 5 is 7. The A came out. The B stayed in. The C came out. I've got 10 divided by 5 is 2. The A came out, the C came out, I'm left with the D. Let's see if it works. Going backwards. 5 times 7 is 35. A, B, C. Yay! 5 times 2 is 10. A, C, D. Yay! It worked. Next one. What's common in 6, 8, and 2? Well, I think it's pretty obvious. Just the 2. I'm only going to be able to take a 2 out, so that's going to leave me with 3x squared plus 4x. Now be careful with this. Minus 1. Now you need that 1 there. That's important. Many of you are going to forget it and you're going to lose marks. But think about going backwards. If we're going to go backwards, it's going to be 6x squared, 8x, and you need that 1 there to get the negative 2. If you don't have that 1 there, you don't get the negative 2. So this is what people will do and get it wrong. People are going to do this. They're going to put the 2 out. They're going to go 3x squared plus 4x. Boom. And they're going to be wrong. They're going to be very wrong, because if we expand this, you'll see you get 6x squared plus 8x, and you're missing that negative 2. So that is very wrong. To do it right, we take out that 2, and we're left with 3x squared plus 4x, but 2x divided by 2 leaves us with the negative 1 there. So let's remember that we need that. Okay, on to the next one. We've got 40x squared plus 10x. Well, I'm going to take a 10x out of both of them. Don't you agree? That's going to leave me with a 4x plus a 1. Look how quick I'm getting. So if I go backwards, it's going to be 40x squared and 10x. Alrighty then, let's look at the next one. Ooh, I've got a 2 times an x plus 1 plus a 3 times an x plus 1. Well, ladies and gentlemen, the only thing common are those brackets. So those brackets are what come out. And then what am I left with? If I get rid of that bracket, I'm left with 2x. And if I get rid of that bracket, I'm left with 3. And that is it. That's the end of the story, people. That is factoring. If you want to check if you're right, well, you just have to think a little bit differently. Take that bracket and put it back in, and you do get 2x times the bracket. Take that bracket and multiply it by 3, and you do get 3 times that bracket. And we're on to the very last one. Let's take a look at it. So what have I got? I've got a 2x minus 3. I got a 2x minus 3. Those brackets are the same. That's all that's the same. So a 2x minus 3 is coming out. And what's left inside? Well, if I get rid of the bracket, I'm only left with 7x. And if I get rid of the bracket, I need a 1. If you don't have that 1, we've got the same problem that we did before. If we lose that 1, we're not going to be able to get back to where we started. Let's take a look. Take that bracket and multiply it by 7x. You get the whole thing. Take that bracket, multiply it by negative 1. You get that. If you don't have that negative 1, then we're not getting this term, and that is wrong. All right, ladies and gentlemen, that's it for your lesson. Hope that worked for you, and you'll have some practice on the LMS. See you soon.